Okay, so for our dynamic wall maze, our 12th VexVR activity, there's actually only going to be one level. The original website file gives us a couple different levels, but they're pretty much all the same. So we're just going to do the hardest level 3 as our only level for this challenge. In our VexVR website, we're going to use the dynamic wall maze playground. So right here, if you don't have it, choose dynamic wall maze. And again, for this one, I've written the code and I'm going to walk you through what I've done. So for our level 1, we can create an algorithm in which the VR robot solves all 9 mazes without any project modifications. So you may be asking yourself, how is there 9 mazes? With the dynamic wall maze, every time that you press refresh here, you can see I'm getting a new maze. And they're saying that there's 9 different ones. So we need to be able to solve all of these mazes without having to change our code. So we're going to use a couple of commands that we've used before, and we're also going to use a couple of new ones. All right, to start, we're going to, as usual, we are going to set our drive velocity, turn velocity to 100% and to speed it up. And then we can start off by turning right 90 degrees. What this is going to do for us is allow us to start facing a different direction than they give us, and allow us to start using these sensors and stuff down here. So we're facing potentially a wall, potentially an open space to drive. And this code then that you see in front of you here, it will work. It will solve all the mazes, but it'll solve it in probably the longest way possible. It doesn't know how to see the entire maze or see which turns it should make. It's just going to follow along the entire right side of the maze until it makes its way to the finish. So some of the mazes may take longer than others, some of them may be pretty quick. When I do simulate this, I'm going to speed it up just so you don't have to sit here and watch the entire thing go through at normal speed. Alright, so once we have turned right, we're going to use a new command. It is this while. It is under controls. It's this one right here. While, right here, this one. It looks very similar to the if then that we've used before, and also looks similar to the repeat, except it does a little bit different. Basically what this one is saying is, rather than repeating it for a set number of times or running it forever, we are going to, while our robot is doing whatever's inside of here, this not down-eye detects red, it's going to run what's inside the while. If that while is not happening, it's going to run what's below it. So that's this down here. So what ours is saying is, while the down eye of the robot, remember we've used the down eye before to detect red, while the down eye does not detect red, then it's going to run this code inside. We're doing not detect red because the majority of the maze looking down is white. The only part that's red is our finish spot. So the majority of the time, we're going to be running this code inside of the when. And the only time that we'll run this code at the bottom is when we get to the finish. So we want to stop moving, we want to stay right on the finish. You can find this not under the operators, and we've used some of these operators before, the multiplying one, but we're going to look for this one, not, right here. This is just taking whatever that down eye detects red and saying the opposite. So while our down eye is not detecting red, it's going to run this if else. And we haven't used an if else yet either. And if else is pretty similar to the if then that we've used, but it lets us add another step. The if then that we've used says if whatever inside of this is happening, then run this code. The if then else is saying if whatever's inside of here is happening, then run this code. If it's not, or else, then you should run this instead. Let's just add that second step to our code. So ours is saying if the distance in front of the robot in millimeters here is greater than, it's a greater than sign right there, is greater than 260 millimeters, then we're going to drive forward for 250 millimeters, and then we're going to turn right 90 degrees, just like we did up here, to again continue that sensing cycle. And then you may be asking yourself, why are we going 250 and sensing for 260? If you remember from the number maze, one of the first activities, these mazes are set up in blocks, but because of the wall thickness and where the sensors are on the robot, it's not going to be the exact 200 millimeters that we've been using. Just from trial and error, it turns out that it's about 250 millimeters, gets us through the maze pretty smoothly, and 260 is just kind of for some leeway if it's a couple millimeters difference between the mazes. So we're going to turn right here. We're going to sense, can we drive forward at least 260? If we can't, then we're going to turn left. That's this else. Remember, that's the opposite part. So if we can drive 260, then we're going to drive 250 and turn right. If we cannot drive 260, then we're going to run the else and we're going to turn left for 90. Obviously, if you can't go straight and you can't turn right, then we might as well turn left. And then, like I said, as we get to the end, we're going to turn right for 270 degrees. Now, what I'm going to do for this, the first time simulating it, is I'm going to use this step up in the top right. This allows us to, you remember when the code runs, if we hit the play button, you can see a green highlighted box going around whatever part of the code is being run at that time. The step allows us to go step by step, and it kind of pauses at each one so we can see what's happening before it just runs the whole code. So I'm going to hit step here. I'm going to say, okay, the first step, it is setting our drive velocity, obviously, setting our turn velocity to 100. Now it's going to turn right for 90 degrees. Should turn right for 90 degrees. There we go. So now, obviously in this maze, we're facing a wall right there. That's not going to work. So it's going to run this while. Well, the down eye does not detect a red. There's no red under it, so it's going to keep running this while statement. If distance in millimeters in front of it is not greater than 260, which if there's a wall right there, it's not, then it's going to run this else. So it should turn left 90 degrees. So see, it checked the first if, couldn't do it, so it's jumping down to the else. It's going to turn. And then it's going to start it all over. There's no red below it, so it'll run the if. If distance in millimeters is greater than 260, we'll drive forward to 250 and turn right for 90. There's still a wall in front of us, so that is not going to happen. So we're going to go down to the else, checking it out, and we're going to turn left for 90. Now, it's going to run it again. But this time, we do not have a wall in front of us. The distance that we can drive in front of us is greater than 260, so we're going to drive forward for 250 millimeters, and then we're going to turn right for 90. There you go, there's the first part. Run it again, drive forward for 250, turn right, still open space, drive forward for 250, turn right, there's the wall. Okay, we can't drive forward, jumps down to the else. And what it does, it just keeps running through this. And you can see here, the next step I press, even though, to solve the maze, we want to go up here. You can see, just because you can see the whole maze, we want to go up. It's going to keep checking to the right. So that's what I was saying at the beginning about how it's going to take a slow path through the maze, but it will eventually get to the finish. So it'll go through this whole side spot here that's not part of the maze, but then it'll eventually make its way to the finish. So I'm going to hit play, and I'm going to let it simulate through the whole maze. I'm going to speed it up for you, and then we'll talk once it's done. Okay, so there we go. We can see now our robot is running this turn right for 720 degrees. It's just kind of like a victory dance. It means we've got to the finish. You can see from that path it took pretty long ways around the maze, but we did eventually make it to our finish and we stopped driving. We did not drive off the map. I'm going to stop simulate. So now you know how the code should work for a maze, but our level said solves all 9 mazes without any project modifications. So in this video, I'm not going to test all 9. We're going to test one more. I'll just hit play. We'll speed through the simulations, make sure it works. But I want for you to test with, a couple of them at least, more than 2, say 3 or 4, and for your screenshots, attach the robot at the finish of multiple different mazes. Okay, so you can see right here, I'm at the finish. So at this point, I would take a screenshot of my code and my robot at the finish, and that would be screenshot number 1. And then do that for at least 2 more mazes. So we have 3 finished maze screenshots of our robot. And then that would be your submission. So let's do one more. So I'm going to hit refresh. Maze changes. Let's hit play and see what happens. And there we go. There's a little victory spin. Okay, so this has solved 2 mazes. I'm going to go and say that it can solve all 9. We needed it to. If yours, again, screenshots of the code and now the robot at the finish. And I want this of at least 3 of the mazes. Okay, so it means you have to go through and refresh and hit play on a couple of them just to make sure your code works. If you have questions on the code that we wrote or what it's doing or anything at all for this activity 12, the dynamic wall maze, please let me know. If not, I hope you enjoyed the video and thanks for watching.